Hi students, today we are going to discuss about Fourier sine and cosine transforms and their properties. Okay, here the Fourier sine transform. What is the Fourier sine transform? Where we got this one from? Okay, as we know that from the Fourier sine integral, this is the formula we have. F of x is equal to 2 by pi integral 0 to infinity sine px into integral 0 to infinity sine pt f of t dt dp. Okay, so just by making some modifications in this, we can get this Fourier sine transform and the inverse Fourier sine transform also. Here, now from this, if I write this part as something like here, we will write this as a Fourier sine transform of f of t. So that is simply we can write that as a fs of p. Okay. So this is nothing but the Fourier sine transform of, we are writing this part as a fs of p. That is Fourier sine transform of f of t. So that is fs of p is equal to integral 0 to infinity f of x sine px dx. Okay, is known as a Fourier sine transform of f of x. Okay, so now if I substitute this in this, then what happens? I will get f of x is equal to, okay, by substituting this one in this, I will get f of x is equal to 2 by pi integral 0 to infinity fs of p into sine px dp. So this is called as, or this is known as inverse Fourier sine transform of fs of p. Okay, when I substitute this one in this, okay, I will get f of x is equal to 2 by pi integral 0 to infinity fs of p into sine px dp is called inverse Fourier sine transform of fs of p. So their Fourier sine transform is with respect to x and the inverse Fourier sine transform with respect to p here. So this is the difference you can observe in these two. Now let us discuss what is the Fourier cosine transform. Okay, here the Fourier cosine transform. Similarly, we have from the Fourier cosine integral, this is the formula we have from the Fourier cosine integral, f of x is equal to 2 by pi into integral 0 to infinity cos px into 0 to infinity integral 0 to infinity cos pt f of t dt dp. Now, just by assuming here this, if we write this part as a fc of p, okay, fc, that is Fourier cosine transform of f of t or f of x. Okay, fc of p is equal to integral 0 to infinity f of x cos px dx. Okay, since it is a definite integral, so it doesn't matter t, we have t here, but we are writing here x. So it doesn't matter, since it is a definite integral, it doesn't matter which variable we use here. Okay, so here fc of p, that is Fourier cosine transform of f of x is equal to integral 0 to infinity f of x cos px dx. So is called Fourier cosine transform of f of x. Next, here, now f of x is equal to, okay, so now if I take this one in this, so there I will get f of x is equal to 2 by pi into integral 0 to infinity fc of p into cos px dp. Okay, is called as inverse Fourier cosine transform of fc of p. Okay, is called inverse Fourier cosine transform of fc of p. Let us discuss properties of Fourier sine and cosine transforms. We already know about a few properties what we have, but here coming to the Fourier sine and the cosine transforms, here these are the properties, some important properties we have. The first one, the linearity property. So that is fs. Okay, fs means Fourier sine transform of a into f of x plus b into g of x is equal to a into Fourier sine transform of p, that is Fourier sine transform of f of x plus b into, this is gs of p is nothing but the Fourier sine transform of g of x. Okay, gs of p is nothing but Fourier sine transform of g of x. So that's what we are writing here as a gs of p. Similarly, fc, Fourier cosine transform of a into f of x plus b into g of x is equal to a into Fourier cosine transform of Fourier cosine transform of f of x, that is fc of p, plus b into Fourier cosine transform of g of x, that is gc of p. Okay, here where fs of p and gfc of p, gs of p and gc of p are Fourier sine and cosine transforms of f of x and g of x respectively. Okay, now the change of scale property. So change of scale property, if fs of p, so that is Fourier sine transform of f of x and Fourier cosine transform of f of x are the Fourier sine and cosine transform of f of x, then fs of f of ax is equal to 1 by a fs of p by a. Just we have to put in place of p by a, since we know that fs of p is the Fourier sine transform of f of x. So that is also you can take fs of p. So you just put in place of p as a p by a. Now similarly fc of f of ax, Fourier cosine transform of f of ax is equal to 1 by a into fc of p by a. The next one, the next property here, modulation theorem. If fs of p and fc of p are the Fourier sine and cosine transform of f of x, then fs of f of x into cos ax is equal to 1 by 2 fs of p plus a plus fs of p minus a. Now here we have fs of f of x into sin ax is equal to 1 by 2 fc of p minus a minus fc of p plus a. Similarly here we have fc of Fourier cosine transform of f of x into cos ax is equal to 1 by 2 fc of a plus p plus fc of a minus p. And the last one, fc of f of x into sin ax is equal to 1 by 2 fs of p plus a minus fs of p minus a. Okay, so here Fourier sine transform of and Fourier sine. Okay, and here Fourier cosine transform. Here also we have Fourier cosine transform. Here Fourier combinations of cos ax and the cos ax along with the function is, if it is given, it's enough to know the Fourier cosine transform of the f of x. Okay, when the f of x into cos, the f of x into cos, it doesn't matter, it's Fourier sine, Fourier cosine. Here the right side also we need to know Fourier cosine transform of f of x. We just put in place of p, a plus p and a minus p, take the average here. But here when I have the combination sin ax along with f of x, in that case we need to know the Fourier cosine transform of that function f of x, and whenever the sin ax combinations we have, so then only we can find the Fourier sine transform of f of x into sin ax and Fourier cosine transform of f of x into sin ax. Okay, by using these two formulas. Okay, here the important results we have. First one, Fourier sine transform of the derivative f dash x is equal to minus p into fc of p, and the second one, fc of f dash of x is equal to minus f of 0 plus p into fs of p. So as you know, the Fourier sine transform of the derivative of f of x, okay, f dash x is equal to minus p into fc of p, and Fourier cosine transform of derivative, that is f dash x is equal to minus f of 0 plus p into Fourier sine transform of p. And now the second one here, and this is one of the important, fs of x into f of x is equal to minus d by dp into of fc of p. Okay, Fourier sine transform of x into f of x is equal to minus d by dp of fc of p. Similarly here fc of x into f of x is equal to d by dp of fs of p. Here any combination like x into e power x, if you know the e power x, Fourier cosine transform of e power x, then if we are asking to find the Fourier sine transform of x into e power x, then you can use this formula. And similarly, we know that the Fourier sine transform of e power x, and asking to find the Fourier cosine transform of x into e power x, then we can use this formula. Not only e power x, we can use any other functions also. We can apply this important formulas. Okay, thank you.